Good morning, everybody. I want to make a video with another example of the sampling distribution for sample proportions. I know this is what we worked on in class, but I think it's sometimes helpful to see it again. Use this as you're working on the practice problems and see what you can do. So we're going to hop right in here. Our example says about 75% of young adult internet users watch online videos. This 75% is what we call the population proportion, okay, or P equals 0.75. Now, I don't know where that's coming from, and in the big scheme of this problem, what we're going to do is see whether or not we really trust that number based on our sample, but wherever that is, that's what we're treating as a population proportion. So say that I take a sample, okay, and it's going to be key here that this is a random sample that's going to meet our random condition. Okay, so we don't have to necessarily check that again because it's right here. Of 1,000 young adult internet users, 786 respond that they watch online videos. That 786 is going to become our p hat when we divide it by 1,000. Okay, and that's going to give us 0.786 as a sample proportion. And so we're just breaking down the parts of what's going on here. We want to look at the mean of the sampling distribution. Remember that the sampling distribution is what would happen if I took lots and lots and lots and lots of samples of 1,000 and I kept getting these numbers. They're going to be different every time, but what happens if I averaged all of those? And what we saw, remember, is a formula that says the mean of the sampling distribution is equal to the population proportion. So it's going to be our 0.75. Okay. We'd like that. Okay. If we take lots and lots of samples, it gets close to our population proportion. The standard deviation is going to work as long as the 10% condition is met. So I'm actually going to check the 10% condition first by saying that 1,000 is less than or equal to 1/10 of the population size. And this is what I mentioned in class. I don't know the population size. They're not telling me how many young adult internet users there are, but it's a lot. If I multiply both of these sides by 10, I'm going to get 10,000 is less than or equal to n. Again, I don't know what n is, so I don't know for sure that 10,000 is less than that. But I think it's reasonable to assume that there are more than 10,000 people between ages 18 to 29 that use the internet. I think that's a reasonable assumption. So we're going to write reasonable to assume more than 10,000 users. Okay. There are going to be cases like that. Sometimes you're going to have to think a little bit, is it reasonable? But generally speaking, we probably have millions of young adult internet users. 10,000 is going to be less than 10% of that. So that allows me to come to my standard deviation formula, which again was P times 1 minus P over sample size. Noting that you do want to use your population proportion, not your sample proportion. So this is going to become the square root of 0.75 times 0.25 over 1,000. I can do that all in the calculator at once if I'm good. If not, just do it in a couple steps. If you want to do it all at once, that's what your screen should look like here. I'm sorry, blocking some light a little bit. Slide that over. And that's going to get me 0.014. Make sure you're just really careful with decimals here, because I made this whole video earlier and realized that I forgot that second zero. Okay, so we're going to redo it. All right. Is the sampling distribution approximately normal? This is based on our large counts conditions. We want at least 10 successes and at least 10 failures if we took our sample size times our population proportion, and our sample size times 1 minus population proportion. Okay, so 1,000 times 0.75 is 750. And, 1,000 times 0.25 is 250. So we do have more than 10 successes in this case and failures in this case. So since that's met, okay, the sampling distribution is approximately normal. What that means is that every time I took a sample, as we made one of those dot plots, as we filled that in, it's going to look like our normal curve does. Okay? And what we will know is that it's going to be centered at our mean, which is 0.75. Okay? So all that stuff that we learned about earlier in the year with normal curves is now going to apply because it's going to have enough successes and enough failures. So this next question, what would happen if our sample size were 9,000 rather than 1,000? Okay? We need to look at where little n shows up. It's going to show up here. But all that's going to change is make these numbers higher, 9,000 times 0.75, 9,000 times 0.25. So it's still going to be approximately normal. So it remains approximately normal. The big question for us is, does it still meet the 10% condition? Because 10% is a limit, an upper limit. If I'm increasing the sample size, I want to be careful of that. So 9,000 less than 1/10 n. Multiplying by 10, I get 90,000 less than n. I still don't know how many there are, but I'm still thinking that in this particular case, it's reasonable to assume there are more than 90,000. Okay. There are going to be problems where maybe that reasonability is questioned by increasing the sample size. So we can't just blindly increase our sample size, but it is going to be still there. The other place it shows up then is in our standard deviation, and what's going to happen is that our standard deviation is going to change and it's going to get smaller because when we increase the size of our denominator, right, we're going to decrease the overall answer. So I'm going to go back in, and all I'm doing is changing this to 9,000 now. And now it's going to be 0.005. So it's going to decrease the standard deviation. In general, a larger sample size is better as long as it still meets those conditions and it's reasonable to obtain that sample size. Okay. But we're going back to our 1,000. So this is the big question here. What's the probability of obtaining a random sample of young adult users, or of 1,000 young adult users, in which 78.6 or more say that they watch online videos? Now I want to think back to our normal curve as we talked about earlier in the year. This is our mean. Our standard deviation moves out. So if I do, looking at making these numbers larger, 0.75 plus 0.014, that's 76.4. And then 77.8, and then 79.2. So 1 standard deviation, 2 standard deviations, 3 standard deviations. My 78.6 in the sample is really going to fall probably out here based on what I just saw. Okay, 1 standard deviation, 2 standard deviations, 3 standard deviations. I'll drop those in there, okay? So what I'm looking for is what's the probability of getting that number or above? Because I'm above my mean. Okay, so how much of the data fits in that little piece of the curve? And that's an important question because if it's unlikely to happen, that might give me evidence to question whether or not this is actually true, or we need to maybe do some more research. Okay, so as I'm coming down here and finding that probability, because we were normal, we can use our normal CDF to do that. Thinking about, sorry, I'm off camera a little bit there. This picture, I want my lower limit to be the 0.786, and I want to keep going above that. So if you are responding to the prompts, your lower limit is 0.786. Your upper limit is just a really big number. I like to use 100,000. If you are using the TI-83, you're just going to type these values in separated by commas. You're not going to type in the words. U is now the mu I calculated up above, which again is just our population proportion. And standard deviation is the 0.014. If we had decreased the standard deviation, those numbers are going to change. This is going to get further outside. Okay, and that's why a bigger sample might help us get a little bit more evidence. So I was just writing that down. If I'm in my calculator, second distribution, back to normal, at 0.786, and I think I went more than 100,000 there, but that's okay. 0.75, 0.014. And so if you're typing it in the TI-83s, this is what it should look like. And you'll see it gives me a probability of 0. Oh, and then I'm going to recognize that I messed up because I forgot my decimal. So I'm going to have to go back to my distribution. Sometimes it's okay to make sure. Everything else is good. And I'm going to get this value. So 0.005. And so that's our probability. Remember that this is a 0.5% chance. So there is a 0.005 probability, an extremely low chance. And I am writing all this out. It is important that we do get used to writing this. And I know it's a lot, but I'm really just recopying this portion of the sentence. 1,000 young adult internet users. I want to be specific. Okay, I can't just say internet users because that's not what I sampled. Right? I can't just say young adults because that's not what I sampled. Young adult internet users, which 78.6% or more say they watch online videos. Okay, so hopefully that helps you move more quickly through these when you're working on them on your own. But check that out, try those problems, and then in the next unit we're going to follow up, or a couple units, we're going to follow up with how we deal with what happens if we're questioning why that probability is so low. Thanks.